Which experiment is this?
Sir, mine is first experiment and sixth experiment.
Okay, first and sixth grade.
Uh, my, my first experiment is study of field patterns of waveforms inside a rectangular waveguide. Actually, a rectangular waveguide is a hollow tube with a rectangular cross section. The conducting walls of a waveguide confine the electromagnetic fields and therefore guide the electromagnetic wave. Here we can see an image of a rectangular waveguide, and mode is an eigenvalue which corresponds to a cutoff frequency below which the mode cannot exist in the guide. The main major types of modes are TE, that is transverse transverse electric, and TM means transverse magnetic, and TEM is transverse electromagnetic. Actually, actually, TE mode means electric field will not have any component in the electric field will not have any component in the direction of the propagation. That is, Ez will be equal to 0, and Hz will calculate by C cos mx pi x by A into cos n pi by B into cos n pi y by B. We use
Yeah, can you directly move to the demo?
okay, sir. Sir, first experiment, no, sir.
Yes, first experiment.
First,
Field pattern of various modes.
so first we can uh, set the frequency here. So I take 6 gigahertz for now, and I set it here for TE mode. That is, electric field will not have any component in the direction of propagation, and we'll see the pattern of electric field in the rectangular waveguide. If we run this, and we can see the patterns in XZ mode, that is this this side, and in XY we can see this will be the pattern, and YZ. If we change the mode MN values, you can see here, the patterns will change according to it, and for in T mode, if we give values for M and N, uh, M and N as 0, here it will not, this mode will be not exist in this plane, because if we calculate using Hz formula, will get a will not get a correct value. So in this plane it will in this mode will not is only not existing, and the modes existing are 0 1 1 0 and 1 1, so on. Now we see for TM mode. TM mode is the in which the magnetic field will not have any component in the direction of propagation. We'll set it as TM here. Then we'll keep the same frequency. Then if we run here, as the modes are 0 0 comma 0, so it will not in this case also, for M and N is equal to 0 in TM mode, it is not existing. And if we apply 0 1, the mode will be not existing, because if we calculate using formula sin m pi x by A into sin n pi y by B, we can know that this mode does not exist. The mode will be existing for values m and n 1, and we can apply m as 2 and n as and 2 and more and so on. Here we can see the electric field patterns in the rectangular waveguide. If we change it to magnetic field, here we can see the magnetic field pattern in the how it will be in a rectangular waveguide. Sir,
Why in the 0-1 mode it is not visible or not field pattern is not available?
sir, if we use for formula, sir, as in TM mode, Hz will be equal to 0, sir.
Okay.
So we'll be having only Ez. We'll calculate using sin m pi x by a, sin n pi. When we apply their 0 for m value and n value, we'll get an indefinite value. So in that, this pattern will not be existing, sir.
And for 1-0?
Sir, for 1-0 in T mode, it will be existing. Here we can see.
1-0.
1-0, we can see that magnetic field pattern is
ಇದರಲ್ಲಿ 0-1 ಬರಲ್ಲ. Okay. Continue.
Next experiment I will show.
Yeah.
Sir, next is the Smith chart. Smith chart, introduction to Smith chart, and for finding the impedance, unknown impedance. Actually, is Smith chart is an Smith chart is a family of circles and arcs, and it consists of here we can see that it consists of circles and arcs. Here the circles represent a real part and the arcs represent imaginary part. This circle is defined as a constant resistance circle, and these arcs are defined as a constant reactance circle. And in this experiment, first we will set for a resistance circle, and we will as we have set for only resistance circle, we will not consider reactance. We will take resistance values. If we change the resistance value, we can see here that the circle size gets changes. Actually, the whole circle value of normalized resistance. As we have not taken the value of reactance, here that it will be 0 in the imaginary part. Actually, using this Smith chart, we can calculate the normalized load point. If we put this to here, if we give values for both the normalized reactance to be plotted and normalized reactance, you can see that this circle represents the resistance, and this arc here represents the reactance. Where circle and reactance, circle and arc meets, that this is here. This point we get to know what is the value of a normalized load or load point. So in this
what kind of load it will be?
Sir?
What kind of load it will be when you get that point on the upper side of your Smith chart?
Upper, sir. What kind of loads? Sir,
is it a capacitive reactance load or inductive reactance load?
Sir, for upper side it is capacitive, sir, and for if the value of reactance is negative, then it will be for reactance will be downer side, sir. Downside,
Okay,
and
but
sir,
yeah, fine. Continue.
and here we can see the this point where it intersects is the normalized load point, and if we give negative value for the normalized reactance, the arc will come.
Then shift ಆಗ್ತಾ ಇಲ್ಲಲ್ಲ.
ಹಾ ಸರ್ ಅದೇ ಸರ್ ಏನೋ ಆಯ್ತು ಸರ್. ಸರ್ ಇನ್ನೊಂದ್ಸಲಿ ಓಪನ್ ಮಾಡ್ತೀನಿ. If reactance circle, if we see sir, here we can see that if we consider only negative reactance, the arc will be downwards, and if we take both resistive and load point.
ಮೇಲ್ ಶಿಫ್ಟ್ ಆಗ್ತದೆ ಈಗ ನೆಗೆಟಿವ್ ಇತ್ತು.
Sir, when we calculate, we will get a normalized load point of 1 plus 1i, sir. So 1 plus 1i is in a real is in a upper part. So,
Okay.
upward, sir. And here we can change the load parameters. I will take here as 25, and load reactance is also 25. And if we enable this VSR circle, here we'll get one more circle, that is VSR circle. And
What is that circle called? What are the information you will get from that VSWR circle?
Sir, we sir
Okay, let it be. Yeah, you can stop presenting. Continue with the next one.
sir, then one more thing is that, sir. Sir, here we can see the movement on transmission line. If we enable it and increase the wavelength,
Yeah.
we can see that that blue line occurring shows that it is moving towards the generator. If we select it as towards the load, we can see that it will happen. It will increase. A blue color line arc will increase towards the load.
Okay, okay.
Actually, this circle consists of lambda by 2 as its distance will be lambda by 2.
Okay. Where transmission line wavelength.
Yes, sir. Transmission line wavelength will be lambda by 2. And if you want more, we can increase according to.
Okay. Next.
Sir, Akash, sir.
Okay. 30